In this video, we're going to focus on the variety of chemical reactions involving the metals of the periodic table. Metals play such an important part in the world around us that it's important that we understand how they behave and react. So what scientists have done is they've taken a range of metals that we find on the periodic table and they've compared each metal with the way that they react when added to oxygen, water, or if I heat it, steam, and even dilute acids. And they've looked to compare the reactions. Some reactions are violent with explosions. Some reactions, there's vigorous bubbling. Others, there's a little bit of fizzing. And in some metals, there are no reactions happening at all. Scientists use this to put together the reactivity series. But before we look at that, we need to understand the general reactions of metals. We need to be able to memorize them so that we can apply these to whatever metal the exam board gives us. So if we react a metal with oxygen, it's always going to produce a metal oxide. For example, calcium plus oxygen will produce calcium oxide. If I take a metal and react it with water, it's going to produce a metal hydroxide plus hydrogen if it is a reactive metal. Or if the metal is slightly less reactive, I might only get a metal oxide plus hydrogen. Hydroxides and oxides are both bases. And look, there's hydrogen. I know hydrogen is produced because a burning splint goes squeaky pop. And finally, if I add an acid to a metal, I get salt and hydrogen. For example, calcium plus hydrochloric acid will give us calcium chloride, which is neutral, plus hydrogen gas. And now we can sit back and have a look at the reactivity series that as scientists we've been able to put together and helps us to remember how different metals are going to react. We start off with group 1 metals at the top and we work our way down group 2, aluminium's in group 3. We have some transition metals like zinc and iron, tin and lead in the middle of the reactivity series. And then hydrogen separates some of the metals that are the least reactive, such as gold, silver, and platinum. So as we go down the reactivity series, it's important to remember that the reactivity decreases. Now this can help us to predict a lot of information. When we mine for metals, the ore or the rock usually contains the metal in the form of a metal compound. And depending on the reactivity, that helps us to decide what method is used to extract it. For example, the most reactive metals are extracted by electrolysis. The least reactive metals, they are panned or found as elements on their own, so they don't need to be extracted from a compound form. And those metals of medium reactivity are extracted by the reduction process using carbon. And this is less expensive than electrolysis. Let's take a moment to focus on reduction by carbon. So iron comes out of the ground in the form of hematite and it's found as iron oxide. Because carbon is more reactive than the iron, we can use this displacement reaction to help to extract iron from the iron oxide. Let's have a look at this reaction. Iron oxide reacts with carbon, and there it has produced iron on its own, which is what we want, plus carbon dioxide. Let's look at this reaction more carefully. From iron oxide to iron, you can see that oxygen has been removed. We call this reduction. On the other hand, if you look at carbon in the reactants to carbon dioxide in the products, you can see that oxygen is added. We call that oxidation. So you may remember that we've also discussed oxidation and reduction in terms of electrons. It can also be defined in terms of oxygen gain or loss. And in this reaction, because oxidation and reduction is happening, we call it a redox reaction. We can also explain this in terms of displacement reactions. If we look at the previous example, we said that carbon was more reactive than iron if I look at its position on the reactivity series. So to use an analogy, iron of medium reactivity is going out with a gorgeous girl. And then along comes carbon. Now carbon has a bit of a six-pack, is rather gorgeous, and oh dear, he outcompetes iron completely. So carbon dioxide gets to have the girl forming carbon dioxide, and poor old iron, because he's less reactive, he is left all on his own. Let's have a look at another example. In this example, zinc oxide reacts with calcium. Calcium is more reactive than zinc on the periodic table, so a chemical reaction will take place. Poor old zinc thinks he has the gorgeous girl oxygen, but then, yes, along comes calcium, and all his work in the gym and his incredible personality has obviously paid off, because else calcium gets to kick away zinc, and he gets to bond with oxygen, and left all on his lonesome is poor old zinc. Mining can be incredibly destructive to the environment, and we also know that some metals are in very short supply. So scientists have come up with biological methods of extracting the metal from the environment. The first method is known as bioleaching and involves bacteria. Bacteria absorbs the metal from leachate, which is water that has perforated through rocks, and we can then extract the metal from the bacteria. Phytomining is a method that involves growing plants in soil which is rich in a metal such as copper. The copper is absorbed by the plant and builds up in the plant material. The plants are harvested and burnt, and the metal compound can then be extracted from the ash and separated. And that brings us to the end of this whirlwind tour of metals. It's now time to sit back and reflect on what you have learned. And the best way to revise is to test yourself. So you can pause the video and see if you can answer these questions. Remember, the more you practice, the more time you give yourself, the better you get.